Good day, friends. Today we will be talking about LSTM, long short-term memory, a special type of neural network, and an evolution from RNN, recurrent neural networks. To start with the introduction, long short-term memory (LSTM) is an advanced version of the recurrent neural network designed by Hochschild and Schmidberg in 1997. LSTM can capture long-term dependencies in sequential data, making them ideal for tasks like language translation, speech recognition, and time series forecasting. Unlike traditional RNNs, which use a single hidden state passed through the LSTMs, introduce a memory cell that holds information over extended period, addressing the challenge of learning long-term dependencies. So long-term dependencies are coming out, so we have to segregate between short-term memory and long-term memory, and which is useful to our network. Problem with long-term dependency in RNN, recurrent neural networks are designed to handle sequential data by manipulating a hidden state that captures information from previous time steps. However, they often face challenges in learning long-term dependencies where information from distant time steps between becomes crucial for making accurate prediction for the current state. The problem is known as vanishing gradient or exploding gradient problem. What is vanishing gradient? When training a model over time, the gradients which help the model learn can shrink as they pass through many steps. This makes it hard for the model to learn long-term patterns since earlier information becomes almost irrelevant. Then exploding gradient, sometimes gradients can grow too large, causing instability. This makes it difficult for the model to learn properly as the updates to the model becomes erratic and unpredictable. Both of these issues make it challenging for standard RNNs, recurrent neural networks, to effectively capture long-term dependencies in sequential data. So here is our architecture of LSTM on a high level view. We have input, output, and transformations are going on in the machine, and we are feeding long-term memory while calculating the output. So there are three types of gates in LSTM architecture: input gate, forget gate, output gate. Input gate controls what information is added to the memory cell. Forget gate determines what information is removed from the memory cell. Output gate controls the information is output, what information is output from the memory cell. So here is the total LSTM architecture. We have forget gate, input gate, output gate. Forget gate is the instruction for long short-term memory neural networks. LSTM architecture allows LSTM networks to selectively retain or discard information as it flows through the network, which allows them to learn long-term dependencies. The network has a hidden state which is like its short-term memory. The memory is updated using current input, the previous hidden state, and the current state of the memory cell. LSTM architecture has a chain structure that contains 4 neural networks and different memory blocks called cells. Information is retained by the cells and the memory manipulations are done by the gates. We start with forget gate. The information is no longer useful. The information that is no longer useful in the cell state is removed with forget gate. Two inputs xt and ht-1 previous cell output are fed to the gate and multiplied with weight matrices followed by the addition of bias. The resultant is passed through an activation function which gives a binary output. If for a particular cell state of the output is 0, the piece information is forgotten, and for output 1 the information is retained for further use. Then we have input gate. The addition of useful information to the cell state is done by the input gate. First, the information is regulated using the sigmoid function and filtered the values to be remembered, similar to the forget gate using inputs ht-1 and xt. Then a vector is created using tanh functions that gives an output from -1 to +1, which contains all possible values from ht-1 to xt. At last, the values of the vector and the regulated values are multiplied to obtain the useful information. So that is input gate. About output gate, the task of extracting useful information from current cell state to be presented as output is done by the output gate. First, a vector is generated by applying tan h function of the cell. Then the information is regulated using the sigmoid function and the filter by the values to be remembered using inputs ht-1 and xt. At last, the values of the vector are regulated and the regulated values are multiplied to be sent to an output and input to the next cell. That is the general structure. We have applications of long short-term memory neural network in language modeling, speech recognition, time series forecasting, anomaly detection, then recommender systems, video analysis, etc. I'll stop here. Thank you. The entire talk is based on the article from Geek for Greeks. Thank you. Like, comment, share, and subscribe my videos. I am available for one-to-one sessions too. Thank you.